Okay, problem number 2. Tom has a meeting that begins at 6:13 p.m. He lives 8 hours and 23 minutes from the main office. What time does he need to leave his house to be at the meeting on time? So this problem, we're actually going to go backwards in time. So when we set up our number line, which I'm going to do right over here, we are going to start at 6:13. And we're going to need to go backwards 8 hours and 23 minutes. So if I go backwards in my hours, and we've got 1, and that makes it 5:13. Another hour, 4:13. Another one, 3:13. 2:13. 1:13. Let me see how far we've gone so far. 1, 2, 3, 4, 5. 12:13. Now I'm getting right around that 12 o'clock mark. So right now I'm actually at PM, but once I go before 12, I move into AM. 5, 6. So when I move here, now I am at 11:13 AM. And I think I have 1 more hour to go, so that is 10:13. Okay, so now I'm at 10:13, but I still need to go back 23 minutes. So I'm going to actually go back 3 minutes first. So a little baby hill first here. And that's going to get me at 10:10. And that's just going to be a lot easier to work with. Now I still have 20 more minutes to go backwards. So I'm going to go back 10 minutes at a time. Here's 10 minutes. So now I'm going to put me right at 10 o'clock. And another 10 minutes will put me at 9:50 a.m. Now, to double check that, I'm going to go ahead and count forward 9:50 a.m. And I'm going to go forward. I'm traveling. This would time he would leave his house, and he would travel 8 hours and 23 minutes and make sure he would get there on time at 6:13. So if I'm at 9:50, 10:50, 11:50, 12:50, I'm in PM now, 1:50, 1:50, 2:50, 3:50, 4:50, 5:50. So now I'm at 5:50 with my hours. Now if I add 23 more minutes, and there is a way you can do it mathematically, which some of my students do, but I'm going to go ahead and stick with our method. I'm going to do 10 minutes and make it 6 o'clock. And then I'm going to go ahead and jump 10 more minutes and make it 6:10. And then my 3 minutes, and then I am back to 6:13 p.m. So he would need to leave his house at 9:50 a.m. So that indeed is our answer for our elapsed time. And I'm going to go ahead and pause it here, and then I will start the third problem.